RLC parallel circuit has a different impedance. So just please be careful about when you're pulling a generic equation for impedance. Remember, it is specific to the setup. All right, let's do some numbers. So let's say I got 60 hertz here, and RMS value, VRMS, we'll just say is 120 volts, just randomly picking a number. Let's make this 1,000 ohms. I'm now going off memory, this might be a mistake. And 4 microfarads. Let's figure out the equations. All right, so, well, first off, what's my angular frequency?
2 pi times the frequency.
So this is 2 pi times 60, which is something.
120 pi.
Yeah, what, I think this is 370, somewhere around there.
377.
377? Yeah. All right. For some reason I still want to go to 370. All right. So 377 radians per second. My RMS value is 120 volts. What's my peak value? Probably not Ohm's law on this one.
Is that the one where it's just times the square root 2?
Yeah.
So 169.7.
So what is it again?
169.7.
There's the one that's right next to the 70. All right, volts. So my equation for my resistor, sorry, my power supply, is 169.7 volts times the cosine of 377 radians per second times time plus whatever the phase happens to be. We'll just go ahead and establish 0. My capacitive reactance, well, I got a formula right there, 1 over omega C. So this becomes 1 over 377 radians per second times 4 times 10 to the -6 farads. So we'll end up with seconds per farad. I might change the number once we get this. I want it to be somewhere in the same ballpark as 1,000. I think we'll hit it.
663.
What'd you get?
663.
Okay, close enough for me. So my units, based upon my equation right here, would be seconds per farad. But what is the shorter version of those units?
Ohms.
Yep. And I saw a couple of videos where people were going through this, and they didn't bother telling you what the capacitance was. They just went ahead and told you the capacitive reactance of the problem. So my impedance for this problem is the square root of 1,000 squared plus 663 squared. So what is the impedance?
$1199.8.
1199.8 units. Okay, that was complicated. Yes, that's the answer.
Units are still ohms.
Still ohms, yes.
Oh,
So I can now find my peak current from this equation right here, because I know that 169.7 volts is equal to my peak current times 1199.8 ohms. And so my peak current
.14 amps.
0.14
Yep,
in units.
amps.
So I got part of my equation for the current flowing around my circuit here. I was about to put a subscript there, but it's the same, the current's the same for everything. So this would be 0.14 amperes times the cosine of 377 radians per second times time plus that we don't know yet. Because my current and my power supply are out of phase. And that we'll have to wait till next week. But the lab that you do the Wednesday of next week,
Thursday.
where you're working with this, I originally did not do AC, the brief history of doing AC, I originally did not do AC, because when we got to the point where we finished up Ampere's law with Maxwell's correction, that leads very nicely into deriving the speed of an electromagnetic wave, which goes very nicely into relativity. And that's the way I did it. And then I had a student who went to NC State after this to do electrical engineering, and he sent word back that it really would have been nice had they done AC here, that he had seen it before he got there, which is why I do AC now. So, this lab I originally did not do for a while, but one thing nice about the lab is that there are parts of it with the 1% error would be too much. Something's gone wrong if you've got 1% error on some certain parts of it. So, and then the final results, I think the first time I went through it, I was 11% off. And some students have gotten better than that. Just, it is one of the better labs in terms of results, especially after you've done the magnetic wire, the magnetic forces on wires. It's nice to occasionally get a lab where the results come out really nice. So think of it that way. Anyway, I hope all of you have a great day, great rest of the day tomorrow, and see you Thursday. Which of course will be great because we'll be doing physics again.
Did you get your good night stuff submitted?
When did they send it back?